Okay, so imagine this, 10 years ago. I joined a team of people that were trying to revolutionize the way how you consume live sport in general. And people were calling us the Netflix for sport. That was amazing. So first year, we deliver our Monolith backend, frontend. We targeted roughly 10 platforms. Vast majority of our customers were watching content on living room devices. So we had several set-top boxes, console, web, mobile, you name it. And the challenge arose after the first year. We launched, massive success in Japan. Started to have a lot of rights holders that were asking us to obviously work on, to have them in our platform. And the problem is we were working with external companies and we wanted to internalize everything. So imagine your CTO that is coming to your desk telling you, listen, so you know that now we are working with all these people externally, all these companies. Now we need to internalize everything and we need to scale quickly. I was the second tech person hired in the company. So as you can imagine, if it's difficult designing an architecture, think about designing an architecture for people that you don't have. And you know, for the backend, I have a clear path. I just read Sam Newman's book. I thought, oh, seems the microservice is a good fit, so no problem. But for the front end, I had a ton of experience that. I started back in the days with Flash. How many of you have heard about Flash? Perfect. Everyone thinks that it's slow, it doesn't work. I always work with Flash on embedded systems. I put on a Ducati motorbike, I put on a soda dispenser, and it was super slick. As every time, if you don't, let's say, deep dive into the language and the runtime and everything, it's difficult to get performance out of it. And you know, in front end, I have done a lot. I've done a lot also in the back end. But the challenge is, how can we scale the front end? So very often, you know, people think that we take a website, like this one, like an e-commerce, and then we say, okay, perfect. So we have this area, let's say, components, if you want. We break it apart. We have micro-frontends. Yay, done. Not quite. That's the problem. Because the reality is we are back to design architecture, finally, I would say. Many people are thinking, oh yeah, I'm designing the next project. I'm using Angular or React or Redux or whatever it is. Big spoiler, you're not designing anything someone else designed for you. You're just assembling libraries in order to work with specific decisions that were made by someone else. That's not the case of micro-frontends. We are back to architecture. So I was already introduced. I've done quite a lot of talks in the last 10 years on micro-frontends. Wrote a book and also a lot of, I followed a lot of teams. Roughly I count in the last 4 years and a half in AWS, 100 teams, internal and external, that I followed, and I've seen a lot of different implementation. But we need to start first to be on the same page. Because that was a definition that I have to create for the first time that I introduced this concept to roughly 45, 50 developers, that they were staring at me saying, but this guy knows what he's talking about or not? So imagine that back in the days, in 2015, when I thought about this solution, there wasn't the term micro-frontend. I walk in a room, and I had to explain to people that, yeah, you know everything that we have done so far. We're not going to do that in a way. And who is doing that? Asked the CTO. I said, no one. Or better, there were a few companies, but not at the level that I wanted to reach. And therefore, I have to coin a definition. This definition is now the definition of micro-frontends. Many people are referring to that. So it's a technical representation of business subdomain. They allow independent implementation with same or different technology. They should minimize the code shared and owned by a single team. Now, during the presentation, we are going through all these key points that are highlighted in blue, and we are going to see who is responsible for what and how we should tackle them. Okay, let's start for the first part, a technical representation of business subdomain and independent implementation. You know, I'm a huge fan of architecture, and domain-driven design was, for me, one of the key aspects when I'm thinking about the design, because they have such a nice way to divide a system in multiple chunks and categorize that. You can have like a core domain, you can have a supporting domain, you can have a generic domain, you can assign properties to them. And I use that heavily for the back end of my system, and we ended up to have like 250 microservices with a team of 550 techies spread across Europe, so it was like a sizable system. And I use that also for front-end. And that's why there is a subtle difference between micro-frontends and components. Not very subtle, as we will see in a moment. And then independent implementation is the key thing. We are optimizing here for what? For fast flow. We have heard several talks today in these 3 days about fast flow, and that for me was the key aspect. So let's try to understand first the difference between a component and micro-frontend. So let's assume that you're building a component. I thought about the most common component everyone can know, a button. So I create a new button for the design system, and the first thing that I expose is a property called label. Perfect, so we start to use that, and then the product team says, oh, it's super amazing, your button. Now, we want to have also the possibility to add an icon. So let's add the icon. And we expose another property that is icon. And then we start to gain more traction. We want to change the border color. We want also to do different rollover animation. So we expose also that capability. We want auto-size dimension because we have now the possibility to use this button in multiple portals, in multiple countries, and with multiple languages. And finally, we want to use for forms. Therefore, it has to be disabled by default because you know, it's the way how we want to start till all the mandatory fields are filled. But there is a tiny problem here. The button itself is just exposing a bunch of properties, but they don't know how to operate. It's the container of the button that knows how it should use that specific component. So the knowledge, business domain, is owned by the container of a component. And what we are optimizing here is for reusability. So I'm a huge fan of Neil Ford, and you know, you don't have to take my let's say, point of view on this, but probably he's for sure. The reusability is a form of coupling, if you want. Because the reality is, now we want to have this system reuse across all the different parts. And with design system, we will see later, it's not a bad thing, but we need to be careful on how to think about that. But definitely a button is not a micro-frontend. When we think about micro-frontend, we think about a few characteristics. But first of all, is encapsulating its state. If you're thinking about, let's use a global state between micro-frontends, wrong answer. The reality is you don't want to have that, otherwise you are coupling multiple teams. And that's the first problem we have. Second one is context aware. I don't have to explain to a micro-frontends how it should behave. They just need like an ID for a product ID, or it needs maybe, I don't know, the token, and that's it. Sometimes not even that. And it can operate for itself. It defines clear input and output. API contract first, that we discuss a lot on the back end, is valid also here. I want to know, without bothering other people and other teams, what I can use, what events are coming out from these micro-frontend, and what I can interact with. And last but not least is less extensible. That doesn't mean not extensible at all. There are some micro-frontends that are designed in a way that could work in multiple views, fine, but it has to be designed carefully with this definition in mind. So when I was writing the second edition of the book, I was thinking, okay, how can I provide something tangible that people can take away? So I started to create a lot of heuristics because, you know, after seeing hundreds of teams worldwide that are falling every time on the same trap, I started to think about, okay, let's try to provide some heuristic to explain how to think about that. So first of all, a good micro-frontend reduced API that are exposed to the container. And sometimes you have like literally one, maximum two APIs or properties, like for instance, an event emitter that is injected, stuff like that. Second thing is are context aware. We said that. So the state lives inside the micro-frontend, not outside the micro-frontend. Third, don't optimize for reusability at all cost. Your goal here is not reusability. Your goal is fast flow. You are designing distributed system mainly for your organization structure. People at the end don't care. If you go to Amazon.com, this is Micro-Frontend website. Do you care that it's Micro-Frontend, or do you care that you want to buy, I don't know, the next laptop or whatever it is, right? So finally, Micro-Frontends are more coarse-grained than components, okay? So if you start to see that your view has 25 runtime Micro-Frontends, you are dealing with, to a certain extent, a distributed monolith. So you have like a lot of components that are loaded at runtime and with all the drawbacks of a distributed monolith. So the other important thing is Micro-Frontends boundaries are not forever. If you imagine any company that today are designing Anarchy, and this is not only Micro-Frontends. You can say the same for distributed system. So if you design today the boundaries, what is today a core domain can become, I don't know, a supporting domain later on, or vice versa, because the business is evolving. And luckily for us, it's evolving, because otherwise, A, we are out of our job, despite AI. And secondly, it would be quite boring, honestly, doing only keeps the lights on for every single part of the code that we are writing. Therefore, we need to reassess that part. It's extremely important. There are obviously some organizational benefits. As I hinted before, we're not designing distributed systems only for technical benefits. We can scale independently certain parts. In the case of Micro-Frontends, I can cache a Micro-Frontend for longer because maybe the content is more static in certain part of the application, and in other, instead, I want to have a very fast flow. We stress out this implementation when I was working with Formula One. If you go to the new website of Formula1.com, they started to use different level of caching thanks to this approach of Micro-Frontends. But also on the organizational part, there are some benefits. But first of all, you can start to have incremental upgrades. So if a team works in a core subdomain and start to have, let's say, all the people very close, start to have a fast iteration because the core domain is the reason why you exist as a system or as a company, you start to have, let's say, very fast feedback loop that you want to create. Equally, on another domain that it doesn't require to change that often, if you think about in a website, FAQ part or the contact us part, how often do you change in a year? Twice, maybe less. So you can definitely start to decide that part, but moreover, you have also incremental, so you don't have to switch to Micro-Frontends in one go. How often you would say, oh yeah, this is like really spaghetti code, but in reality, we would like to rewrite the entire application. You go to the CTO and say, listen, I need 24 months to rewrite everything. How often do you have a yes from the CTO? I never had it, honestly. But instead, if you say, listen, we want to incrementally update our system, so maybe we can start with 1 page, and then in a month's time will be 3 pages, and then at the end of the year will be the full website. This is something that lands very well with the C-suite, because you create value for your customers as well for your business. There is a decentralization part that is essential. There were quite few talks about decentralizing the architecture decision and also the decentralization of the tech side. But the reality is that here we are talking about people. If you think that to onboard in a journey or move into any distributed system without decentralizing the way how you are operating, but I'm sorry, you're going to find a lot of friction. Team cognitive load. I had like every other week, one team joining the company, moving from 15 techies to 550. So I can guarantee you that with this approach, we started to enable them to produce code in production and release code in production in a month. Because they have a very narrow things that they need to understand, and slowly but steadily over the month, they started to understand the entire system. And finally, bear in mind that you are not scaling only the technology, but also the organization. Organization, engineering culture, and architecture goes on hand in hand. There is no way that you can, let's say, change one part and the other two won't be affected. So either it happens intentionally or unintentionally, but it happens. Okay, so probably few of you have heard about the Conway's law, right? Yeah, few of you, okay, cool. So one thing that I want to highlight is the year that was coined, 1967. Wasn't recognized till late 70s, if I remember well, because at the beginning it says, Melvin, what are you talking about? But the reality is, this is so true. There are certain decisions that completely affect the way how you're designing your system, and the organization is one of them. If you think about that, you can either design an architecture that enables your organization to thrive, or you can design an architecture and you adapt the organization in order to enable the architecture to work. And it's very important, you know, that when we think about decentralization, that we look in the past. I work in a situation like that, where tech leadership set up the platform team, security, architecture, whatever. And then on the other side, they select certain technologies, patterns, you name it. And then they throw on the other side of the fence, where I was, team A, B, or C. The team were growing organically. The communication wasn't controlled at all. There wasn't, I would say, collocation on intents or stuff like that. It was like, oh, we need another team. Let's spin up another team. Then if that team was in another time zone and has to collaborate constantly with another team that was, I don't know, maybe the first team was in India and the other one was in Canada, obviously no one think about, oh yeah, but we create friction in the communication, and that is exactly what happens. When you start to have, if you don't think about how you organize your teams and collocate the team and trying to figure out a way that they collaborate together, surprise, is not going to work very well. So in recent years, we started to see the idea of team topologies. How many of you have heard about team topologies? Okay, a few of you. So the idea is very simple. We start to focus on value stream teams, okay? So stream-aligned teams, those are those. Catalog, onboarding, etc. Those teams are responsible to write the code that goes to production and generate value for the users. But obviously, as we all know, a system is composed by a bazillion of things. We have security, observability, and all the things that we all know. We have also some complicated subsystems. Think about the data. Every team doesn't really need to know how a data lake or a data mesh or whatever other data architecture you want to use works. The only thing that they care about, okay, I pass this data in this way in either, I don't know, an object storage, or I expose a specific API, whatever they decide to have, right? So the data science team enables or facilitates the integration of this stuff to the stream-aligned teams. Then we have the platform team that provides the foundational part for the company and is used as a federated service, right? So, for instance, if you imagine I want a queue, I ask for a queue, they give me a queue, or I'm a self-service, depends how is your model. Most importantly, we have an enabling team, cross-cutting concern. Think about security, think about developer experience. In my opinion, I will add also architecture, but this is another talk. So I want to drill down into platform responsibility, because very often people don't realize that in reality, we need platform engineering also for micro-frontends, or in general for frontend. In a monolith, it's easier to a certain extent, but for micro-frontends, it's slightly different. So I want to share with you what I have seen implemented in several companies that successfully implemented micro-frontend at scale. So first of all, we're talking about this area here, right? And also developer experience. So platform teams is usually the one that you spin up at the beginning and is generating a foundation. And you can call it Tiger team, you can call it core team. I have heard bazillion names around that. I call that in order to align with the other platform engineering practices that maybe you already have in the company. So the problem they have is that in every single architecture that I've encountered in the last 10 years, and I've seen quite a lot, we always touch 4 points, what I call the Micro-Frontends Decisions Framework. This is the foundational part that no matter what, you need to define intentionally or not inside your Micro-Frontends architecture. You need to identify what the Micro-Frontend is, compose it, routing, and communicate. Those 4 points are always there. It's server-side rendering, client-side rendering, edge-side rendering. You always have to think thoroughly about those 4 points. So let's start with the first one, identify. there are two ways. Either you have an horizontal split, that is what you see on the left of this slide, with header, product details, etc., or a vertical split, where you have one page or group of pages. Now, I've seen, let's say, mess up architecture with both. So don't think that one is better than the other one. But there are reasons, depends from reason for picking, for selecting one or the other. So usually if you have a large team and you have a lot of, let's say, domain that might work in multiple areas of your website, you will go with an horizontal split. But usually I discourage to start with that. On the other hand, if you have, let's say, clarity of what you want to have and you want to have a more mild approach with Micro-Frontends, you go with a vertical split because it's more or less having a modular monolith, okay? So you just divide in pages or group of pages your website, you share a bunch of components at build time, not runtime, and you go ahead and build this stuff. So they are not mutually exclusive. In my previous job, we had, for instance, my account that was a combination of user details, payment methods that live in two different domains in our world, and therefore we needed to aggregate them in a single view. So you can say in certain situations I will go with horizontal split, in certain others I will go with vertical split, so no problem at all. Now the composition part is another interesting one. Because usually I will pick client and server composition. There is a reason why I'm not talking about edge-side composition. At the beginning, if I would have done this talk a few years back, I would talk about edge-side includes and maybe some compute on the edge, stuff like that. The problem is I followed a lot of customers worldwide. And apart from some, the majority of the time they were working with one or two regions in the cloud. Sometimes free, but rarely. And when data is gravity. So if you have like data that are, I don't know, in the data center in London, and you have a request in Australia, even if you have compute that is rendering your website in the point of presence in Australia, the data has to be fetched from London. So you have some optimization, but the developer experience for working on the edge is not as great, and you don't have all the capabilities usually, especially if the compute is running on the point of presence of your CDN, that you have in region. And therefore, it's better that you leverage cache in that case, or you use other techniques like in modern frameworks like Next or Astro, that you can use server islands or React server components. But in general, ideally, you don't render on the edge. So in client-side composition, you usually have what I call an application shell, the dotted line of this diagram, where you load one or multiple Micro-Frontends. Usually what I recommend, even if you have an horizontal split in this case, you create what I call a meta shell. Basically, it's nothing more that the shell will load a domain that could be, I don't know, my account, as I was saying before, and then the meta shell knows what it has to load. In that way, you simplify the way how the application shell that is owned by the platform team will work, and you can change independently the rest, so you don't have dependencies with other teams. Same thing on the backend, and the backend, you know, it really depends how it works. So if you have a server-side rendering approach, you can do server-side rendering for every request, or you can do a composition layer, and you have a bunch of microservices that are doing server-side rendering independently, and you compose basically the output of those micro-frontends, or those microservices in a single page. That is a technique that was used back in the days by Zalando, that is fashion e-commerce, and I have a few examples that are available online. The other thing is when you selected the composition, you go to the routing part, and the routing part usually is in the application shell for both. Easy. Finally, communication. So, as I said before, state management, shared, no thanks. What we want to have is an horizontal split, event emitter, custom event, reactive streams. Now, usually the question when I show this slide is, which one do you recommend? My preference goes with the event emitter, and I explain why. Reactive streams, I've seen few teams implementing that, and there is confusion on front-end developers on reactive programming. I wrote a book on that. Trust me, there is a lot of confusion around how to use a stream. Custom events have a massive problem that are bounded to your DOM. So if you imagine you have your tree, You have one micro-frontend is communicating with on the other side of the tree. You need to bubble up the event up to the window. The other one has to listen to the window and then react to that. The problem is if someone, during the propagation of the event, intercept the event and block it, good luck of finding and debug the problem. But event emitter democratizes everything. Event emitter is completely unaware of the structure. It's an event. Everyone in frontend is used to work with events, and is nothing more than an array. If you see the implementation of an observer pattern, it's just an array that you register for an event, and when there is an event emitted, you just go through the array and say, by the way, this is the event that's happening. If you're interested, you react. If you don't, you're not interested, you don't care. Easy. Either you work with horizontal or vertical split, you need to share ephemeral data or let's say more important data, like for instance, the session token. So session token depends from the security posture. It can be in local session storage, not very secure, or better, not the best preference for, in general, for security teams. Cookies better because you have slightly more control compared to the local session storage. I have seen, especially in finance, customers that are using instead web workers, and they store in memory there. So what it means is that basically, if they try to access the website after a while, it might be that obviously the web worker expired, and therefore there isn't any more the token. They need to re-authenticate, but it's exactly what you want for if you are, I don't know, building a bank application, wherever it is, right? So it's not a big deal for them. But in other cases, if you are in e-commerce and you really want to have like a sleek developer experience, user experience, you usually tend to have cookies. Okay, so usually that's how it works. Perfect, so few considerations. The application shell should be owned by the platform team or the core team. Should be as vanilla as possible. Very often I've seen customers that start to use, okay, we are using React for the application shell, and but then we are using Angular or Vue or other stuff. That could be a challenge to handle. Don't set up yourself for creating runtime errors, because runtime errors might be mitigated by a bit of scope creeping and stuff like that. But when they hit hard, because it might work in pre-prod, but not in prod. Secondly is, should be context unaware. If you find yourself that you need to change a micro-frontend, and you need to change also the application shell, then go back to the whiteboard, because the boundaries are definitely not well defined and domain is leaking. You expose the initial configuration and not much more. Very often, you know, when you have a client-side rendering application, the first thing the client-side rendering application does is fetching an API the context. I'm in, I don't know, Vietnam, and I'm using this currency and stuff like that. It's everything related to that. And finally, it should be responsible for routing and composing. So it should be extremely lightweight in general as a rule of thumb for every application shell. Now, at this stage, you will say, okay, so perfect. Now we understand how to design micro-frontends. Now we go on the meaty part. How do we design that, or which library and framework do you use, right? This is like the favorite things that developers has. They immediately jump straight into that. Oh, we are using the latest version of Vue. The problem is that usually works in this way. So I have the developers pitching this idea, and this is me. Right? It's a challenge. It's a shift of mindset mainly. Architects would say it depends, and you are done. That's usually my role. But you know, I'm very pragmatic, so I prefer to instead of only say it depends, understand one thing. This is the question you need to answer. What do you need to express inside your architecture? I give you a concrete example. Literally last week, I was in a meeting with the team that basically they engaged with me saying, listen, we would like to see if module federation is the right way for building micro-frontend. So I said, fine, let's hear what they have. And they started to pitch me all the technical stuff that they are doing. So they had like multiple frameworks they need to support. They cannot control which framework or enforce which framework every team is using, because some teams were external. They have also to have same framework but different versions. So quite a lot of strong things. And I started to ask, okay, but what are the parts that you can influence? oh, we are the platform team, and therefore we need to create something that is, doesn't require us to maintain for too long because we are a small team, there are too many other teams that are working on that. I said, listen, but if you are telling me you cannot control the dependencies, they already have, and surprise, surprise, in 2025 is normal, there are still libraries that are appending themselves inside the window object. Yeah. So you cannot do scope creep because you cannot say, okay, I append inside a specific scope because not even the bundler is capable because they are trying to append themselves into window. And it's a problem because if I have the same library with different version, one override the other one based on how it's loaded. So we have a huge problem. And I said, listen, you are a B2B business. You have a B2B business. The only way to retrieve this information is through your portal. At the end of the day, you don't care about SEO or organic SEO or whatever it is. Just put an iframe. I said, done it. At how odd it could sound, it was when we started to list all the trade-offs of the different options, it was the safest way for them not being on call overnight. And I hate, in general, suggesting iframe because that means that they really cannot do anything. But unfortunately, in that situation, the context requires extreme measures. In other situations, usually they have control on the frameworks, they have control on how to handle specific things, and therefore we can go with a more modern approach. But unfortunately, again, it's not the framework that you need to select, it's the context that you need to understand. Okay, so developer experience is another thing that very often is forgotten. And you don't have to take care immediately at the beginning. You will need to take care during the journey. But try to create guardrails over time. I give you an example. One of the problems with Micro-Frontends is that very often you have like teams that start to add library. They forget about reshaking and they start to have, let's say, the final bundle that is hundreds of kilobytes, is not megabyte. I've seen also that, of final bundle. If instead you create a shift left mindset, where what I was doing in my previous company, we basically defined what were the size of every single Micro-Frontend. Every time that the developer was opening a PR, we were triggering a Lambda function with Webpack or Rollup. We were building the Micro-Frontend and checking that they were inside a threshold of 20%. We basically automated the performance or the size, budget size of our application at the very first moment that we can intervene with the developers. That was when they open a PR. And if they exceeded by that threshold, they had to justify why they wanted to do that. I can guarantee you that we pick a ton of mistakes made by the developers just because they forgot the configuration or they used the library improperly. Updating shared libraries, that is another question I have every time. How can we update the shared libraries without coordinating everything? Depends how aggressive you want to be. But Dependabot is your favorite tool. Dependabot is basically a tool that you can configure, and overnight you just run through all the libraries, despite its monorepos or polyrepo, and you just say, oh, there is a new design system. You bump out the version, you open a PR, done. You can have, I had some customers that were more aggressive. They literally merge also the code. So the day after, developers clone the project, download the latest things, pull them from Git, and nothing works. It's up to you how you want to handle. Maintain the required security posture, security scan. I think this one is quite clear. And any other architecture characteristics that you can shift left, try to think about that. You cannot design distributed system from an architectural perspective if you don't think about guardrails and automation. There is no way it's going to work. Another thing I started to see a lot of adoption is Backstage. How many of you have heard about Backstage? Okay, quite a few. So it's an open source project from Spotify that is a centralized place for creating templates, documentation, and so on. And this one is something that I've seen customers that they implemented across all the distributed system, from front-end to back-end. They can download a template with Micro-Frontends. They already have everything there, so they just need to write code and that's it. Easy. Now, deployment. This one is probably one of my favorite parts. So deployment, I'm extremely, for me, deployment is one of the most important things you need to think when you are designing a distributed system. Because yes, you have like smaller, let's say, artifacts at the end, no matter if backend or frontend, But there are a few characteristics I want to have available. First of all, I need to think about an incremental deployment, no matter what. Frequent deployment, and I want independent deployment. Okay? If I coordinate with other teams every single time, sometimes happen during the year, when you are releasing a new design system and you want to have an entire application you need to coordinate. But if I have these three characteristics on front end and back end, I'm an happy camper. So how do you do in front end? Back end, we know. We have done on microservices bazillion of times. But in front end, you have no idea how often I've seen companies that implement their own solution. So I said, okay, so this is a problem that I cannot take all alone. I need to take like the most prominent names in the Micro-Frontends community, and therefore I work with Joel, that is the creator of Single SPA, Zach, that is the creator of Module Federation, and Matteo, that is the creator of Open Components, so three of the major most adopted frameworks of Micro-Frontends. And we said, listen, I have an idea, but I don't want to do alone. I want that to have, let's say, a working group that we start to socialize the idea, and it took roughly 10 months in 2022. And what we have come up with was a JSON schema. The most simple things. Trust me, during the 10 months, we moved from let's create a plugin for a framework to let's create a JSON schema. That's better. And this one is extremely simple. We have a unique ID, unique identifier, a Micro-Frontend URL where you can find your Micro-Frontend, a fallback URL if you work with multiple CDNs, metadata, we decide to have integrity and version because they usually are the most important things, and then extras. There you can be, I don't know, framework-specific things like Module Federation. If you will check Module Federation 2, they created a manifest JSON. Surprise. Because it's heavily influenced by this. You can have, let's say, I don't know, I want to show this Micro-Frontend only if you are an admin, or only if you are in this specific bucket. So you can handle it in the way that you want. And then obviously, I was thinking, okay, but if I have to request where I can find my Micro-Frontend, it means that it's a network request. And if it's a network request, I can play with Canary release and blueprint deployment. Hence, there is an array here. It's not a unique object. So I can have multiple versions of the same Micro-Frontend. I have just to add the deployment object, and that's it. So what I've done there, this schema is available today, this URL in AWS Labs. We decided to, let's say, open source it. So if you want to check and contribute, feel free to. But it's something that started to be adopted not only from us, because no one was thinking on the idea of discovery service like we have on the microservice world, but for frontend. But obviously, I wasn't happy. The reality is, when I was thinking, Matteo, that was the creator of Open Components, is working with me in AWS. And I was designing these things. I was like, okay, let's do a sequence diagram. And more I was thinking about that and trying to apply in different use cases. This part here was always the same. It was what we call in AWS the undifferentiating heavy lifting. Okay? So we have a service, it's called Frontend Discovery. In a database, we just retrieve what kind of version we need, and then we send to an application shell, either server side, client side, edge side, doesn't matter. Therefore, I said, okay, well, you know what? We're here, we have some time to spare, so let's work on the Frontend Discovery Service. So we created this open source solution that is available here. It's open source also for the reason being that you know, if you want to take inspiration from, if you want to use on-prem, on other cloud provider, whatever, you can. The code is there. We just explain how it works, and currently we have quite a few customers that are implementing that in their production environment. And the idea here is to use something that enables you to be plugged in every single CI/CD. Doesn't matter if it's GitHub Action, it's Jenkins, or whatever you have, because we expose a bunch of APIs on the backend that you can use in order to say, I want to deploy a new Micro-Frontend, I want to have a Canary release with an incremental upgrade of the version of 10% every minute. The system behaves that for you. It will assign a cookie to the person, so it creates stickiness during the experience, and the rollback is literally, oh, sorry, 100% of the traffic on the old version. That is your rollback strategy. Start to think about rebuilding stuff like that. That is not the case. The only thing that you do is just literally telling to the system where you can find the entry point of your Micro-Frontend. That is either HTML or JavaScript, completely up to you. So let's move into the value stream team responsibilities. So we are here in the diagram. First of all, this one is the most hilarious thing that I read about Micro-Frontends for the last 10 years. We are going to use Micro-Frontends because we can use whatever library or framework we want. So ThoughtWorks, rightly so, in the technology radar of 2017, it's called Micro-Frontends Anarchy Antipattern. Because what they realize is if I start to have different versions of the same framework or different frameworks in the same application, they are basically penalizing the user because it has to download way more JavaScript that is needed. And I usually say, Micro-Frontends are not a playground for developers. Okay? So we're not here for building a monster or Frankenstein architecture, as I heard several times, and have fun with different technology. That's not the purpose. We are here to help our customer and our organization to achieve certain goals. So every line of code matters. Second, and most important thing is minimize the code shared. Okay, so this one I was literally grilled for months about that. I had I was walking out from stage with people saying, oh, Luca said that we can duplicate everything. But he doesn't know about dry or the KISS principle, stuff like that. Okay. As you can see, I'm not very young, so I have seen quite a few stuff. But we need to switch our way to think in optimizing for fast flow. And therefore, we need to think about that. Luckily for me, I'm in a good company. So Sandy Metz, in a talk, said that duplication is far cheaper than the wrong abstraction. So I was a developer for several years, almost a decade. Probably more than a decade, but fine. So during that decade, the most amazing thing that triggers me every time, it wasn't always implementing a new feature, it was doing abstractions. Because now I abstract this, and the entire company is going to use that. Unfortunately for me, the vast majority of the time were 2 or 3 people top that were using the library. And then the other nice thing is what we call the diamond antipattern, that they started to basically build abstraction on top of my abstractions. So when I do a breaking change, and they couldn't update the library because they were on top of the library that I created for the first time. And then suddenly, having, let's say, an abstraction library wasn't that smart. Therefore, I came up with some rule of thumb. You tend to reduce external dependencies. That is the goal of Micro-Frontends. Not eliminate, reduce. Okay? So design system, great idea. Login library, great idea, but not everything. I have seen, for instance, a very large e-commerce, American e-commerce, that decided to go extremely granular and externalize a lot of dependencies. They spent 6 months for refactoring that code. Okay? Optimize for fast flow. That's the other thing. This is our goal, our primary goal when we are designing Micro-Frontends. And last but not least, embrace a lean mindset. So we don't have to let's say, analyze every single bit of our decision. There are decisions that could be taken lighter, what we call in Amazon the two-way doors decision, right? So you can go, so we go with that decision. For reverting back, it takes 1 day of work. Fine, we live with that, okay? And therefore, you try also to take a decision not taking every single bit. You want to be sure of everything. You take a bit of gamble, but you take the decision at the very least a moment with the information that you have. Okay, so those are usually some good ideas. Now, I decided to have another heuristic for that, but I need your help. So we have 4 libraries. We have login libraries, analytics library, design system, and data layer. Which one shouldn't be an external library? Any idea? Sorry? Data layer. Winner, winner. Exactly. And why that? Because if I think about the rate of change, logging, I implement high rate of change at the beginning and then is fade out. Analytics, similar. Design system is changing, but not that often. Data layer instead might change very often, especially when you are migrating or evolving your system. And it's domain specific. And therefore that shouldn't be an external library. And I've seen that as well. Last but not least, ownership. In 2025, you won't believe that. Unfortunately, I've seen also this. What I expect from a Micro-Frontends team is that they understand how to code it, testing, deploying, and monitoring. That's the part that usually is missing. No one is looking into that, but instead is key because it's a distributed system. You build it, you own it, you run it, okay? And adhere to guardrails. We are asking to the developers way more than was before. And the reality is it doesn't exist for me, a team that write the code, front end or back end, and thrown on the other side of the fence, doing just testing, and then forget about the deployment and observability. You need to understand if it fails in production, what fails. And if you think that you have multiple Micro-Frontends in the same view, and I don't know, the first line support is saying, oh, we have an error at 3 a.m. in the morning, which team should they call if they don't know which is the team that is responsible for something? You need to understand what's going on. You need to have visibility and improve your logging and visibility inside your Micro-Frontend through instrumentation. So things like, I don't know, LogRocket or Sentry or stuff like that are your best friend. Therefore, what I recommend is think, wherever approach you have, not doing in CI/CD, but shift left towards as close as possible to where the developers have fast iteration. Therefore, on the process of pulling and pushing code. That's not all, obviously. We have seen that a part of the Micro-Frontends ideal platform. I don't underestimate the other things. But those are the things that I share with you are let's say, the most common mistakes that I've seen worldwide. Obviously, server-side rendering, there is still work to do. Nowadays, with modern architecture and modern framework like Next.js or Astro or Quick, we start to see some very interesting and compelling way to build Micro-Frontends in different ways. And I believe that will be a very, very interesting feature. But also, we need to be aware on how we need to design our Micro-Frontend. How can we identify Micro-Frontend? Because if we start to treat Micro-Frontends components on the server side, it's going to be very nasty. Observability is a key aspect. End-to-end testing also. People are asking me if with Micro-Frontend something changed on testing. Usually, unit test and the integration test are the same, but end-to-end testing can change. So that's very important to think about. Security is another part, event management and performance. So in summary, today you have seen what Micro-Frontends are, the team's ownership, so who is responsible for what in the platform part and then on the value stream side, the importance of fast feedback loop, because in every system is extremely important, and having a decentralized mindset for implementing Micro-Frontends. Those aspects are usually the issues that you encounter when you start the journey with Micro-Frontends, and even mature teams are failing on implementing this solution. That's all I got. I hope that you enjoyed and open to any question.